Hey, it's Alan from Hack Gadgets here. Just going to do a quick review on one of these inexpensive solder pots that you can get from China. So this is a 150 watt unit. It has a temperature range of 200 to 480 degrees. It says here that it'll melt zero point 0.3 kilograms of solder, and this is the North American 110 volt unit. Seems like the 220 units are a bit cheaper. I just purchased this on eBay. It was around, I believe, $45 Canadian, shipped to Canada, obviously. And so this is the unit here. It's fairly light. I've used it probably 4 or 5 times now, and it works really well. What I'm going to do is I'm just going to operate this on, this is just a piece of granite from a countertop. And let's plug it in and see how it works. Okay, so we're plugged in. There's basically two operations here. There's a on-off switch and there's a heat dial. So I'll just crank the heat up all the way. We want to melt this solder fairly quick. And this solder pot is, let's see here, it's listed as 36 by 30, and it's 36 wide, so it'll be 30 deep. I didn't actually want this much solder in it, but it actually melted extremely quick, and I got a bit more than I wanted. This is what's in there. This is Ultra Pure by Kester, and it's 6337. Okay, let's turn this thing on, and I'm also going to use a timer here just so we can keep track of this a little bit. Okay, heat's on. Current temperature is 22 point, what is that? 22.7. Okay, so we're up to temperature, and I'll just back it down to the middle here. This has been running for probably an extra 2 minutes. So we're at about 200 degrees, which is probably around its max temperature. I'm just going to take some rosin flux. Just get a clean spot. And there we go. Worked pretty good. have another similar wire. This is a lighter gauge. I'll do the same thing with these ones. A little bit of flux on there. That works nice and pretty well. Okay, so I didn't realize here it actually says there's a max temperature. I have it on max here and I've let it run for probably another 5 minutes. It says the maximum temperature is 480 degrees. Now unfortunately, that's actually past the temperature of this guy. I believe this guy stops working at around 300 and so degrees. Gives me an error as soon as I take a look at that. We can maybe see what this side plate is doing here. Let's see how high we can get if I just move in slowly. Yeah, so about 311 or so. So it's well over 320 degrees. So I don't think we would have any problem reaching, quite close to 480 degrees. Give it another 5 minutes or so. So that would be probably about 15 minutes total runtime to get us up to that temperature with a full container of solder here. So this has nothing to do with the review, but this is just something kind of cool. So after you've used it and during use, you want to clean off some of the oxidized solder on top. And so I just heated this up, and if you can see in this container here, so this is just a container of flux. Usually what I do is I put it in a small container so I can just dip it in without being too gentle, and it'll just cover the soldered wires exactly. And so if I heat up the screwdriver a little bit, this is kind of neat. It'll boil some of the flux in there. And I guess the smoke is actually heavier than air. And this is a cool effect. It actually just sort of sits in there and it looks like a solid. If you move it, it'll actually start wisping around. Really neat. I wonder if I can pour that smoke out. It's just a bizarre effect. Anyway, little added bonus to, I'm sure, some really harmful stuff that I'm breathing in. Okay, so it's cooled down now. And this is just an interesting thing that I've noticed happens not every time, but quite often. Obviously the metal is larger when it heats up, and it constricts a bit when it cools down. But check this out. So this is actually a hole that goes all the way down to the bottom, and it just naturally formed. There was nothing causing that. I can see how far down that is. That's all the way down to the bottom. It's really interesting. Okay, it's pretty cool. It's a slight bit warm. Let's take this apart and see what makes it work. I'm assuming if I take off these Phillips screws at the bottom here, that this thing should open up. And it is unplugged, by the way. Okay. Okay, so the bottom plate just comes off. And here we have, there's a couple power leads that come over to the heating element in the bottom here. There's some insulation in the bottom, and this is obviously insulated wire. Interestingly enough, there's a couple little notches here for, looks like the wire to go under. Although this one doesn't go through its notch. You can see there's two notches here, here and here, although this one just goes around. And this one was obviously through the notch because the cover plate would push that down. And here we have our green ground here coming in, and it is grounded to the chassis, which is nice. Oftentimes on some really cheap items, what you end up seeing is the ground wire is actually not even in the cable. Don't like this too much. I'm gonna fix this somehow. There's a few pieces of this heat resistant shielding here, and this is actually over here, so this is ground, and I'm assuming this is probably a live connection here. So there's two pieces. There's one piece that ends here, and there's another piece that goes over to here. So on this one here, you can actually see that this one is much longer, and then this larger cable. So this one probably ends in here somewhere. This one wasn't long enough. So there is some bare wire right there. Not sure if I like that, since it's very, very close to the ground, especially just the way it was angled in there. Unless maybe it was in like this, but well, either way, that's still not great. I'll have to fix that up. Okay, so here's the on-off switch. So let's see. Well, interesting. Oh, okay, yes it is. So here's our hot comes in here into the switch. And wow, so this wire here is soldered. This wire here is soldered. And interesting, this is actually a push-on connector which has been soldered. Yes, it has been. I don't think very well though. If I twist this a bit, I bet you that would pop off. So, okay, I'm going to have to fix that also. And I can see why this is a push-on connector. I guess if they're thinking this is a heating element here, it could run over to here and cause some heating. Okay, so let's take this portion out and take a look at this board here. Okay, so I've got access to this board now. It's really simple. There's this dial on the front. So once this dial is taken off, and to do that, all you have to do is, let's see if we can focus on that. There's just a set screw on the inside, and that set screw is just basically holding on to the shaft of the potentiometer here. Once you have the dial off, there's just a nut here. You unscrew the nuts, and this whole board is now free. I'm actually not very impressed by how this is wired up. I've just had a quick look at it, and maybe I'm seeing things, but I don't think so. Okay, so in here, this fuse holder cap was actually off. probably rattled loose in shipping. It actually clips together quite nicely, so I'm actually surprised that this was off. And we have a 3 amp fuse in here. It's actually CSA approved fuse, so I'm quite surprised, as well as a few other ratings, such as I believe it was CE, etc. Now that's sort of where it goes downhill from there. Now I'm not really familiar with these red and blue color codes. Here in North America we use white and black. White is neutral and black is hot. But you can just confirm what colors are what with the trusty plug here. So in this position here, ground. I'm just taking a look at an outlet that's on the wall here. The narrow slot in the outlet is the hot. So this is basically hot, and this is neutral. So first thing I did is just to make sure that the ground wire is actually continuous, and it is. That's awesome. And we'll take a look at hot next. So I'll just do a continuity check for hot. And nice to see that hot comes directly. This is the blue wire here. It comes directly into the fuse. And the neutral was the other red wire here, which goes over to the switch. Now, that's a very odd configuration. I've never seen anything wired like this before. And I took a look at some of the online documentation, and as far as I can see, in the UK, neutral is normally blue. So anyway, it doesn't matter. I like that it goes through the fuse first. However, I hate that, well, some of these other things here. If you can take a look here, this is how they've connected up to the circuit board. They've just tacked it onto the bottom of where the switch gets connected. Now there is a solder spot right here. However, there's no way to access it since the fuse is there. So what I'm thinking is probably in the initial design, the fuse was a lot smaller, the fuse holder, and it only maybe went from here to that first solder spot on the bottom there, and then this wire would just be through-holed from the top, just like this red wire is over here. This blue wire would be feeding into there and soldered in place instead of just, you can see it's just tacked onto the bottom there, which is horrible. Another horrible connection onto the bottom, as far as I'm concerned, is one other side of the heating element. You can see it's just tacked right onto there. And yeah, just not too impressed there. Okay, so if we follow this through, hot comes into one side of the fuse, it exits the other side of the fuse, and enters the circuit. There's basically only one power device on here. I took a look, that's just a triac. And there is no temperature sensing at all. The only leads that go into the circuitry itself is just the power wires. So obviously as you increase or decrease the value of this pot, it's just pulse width modulating this triac here to increase or decrease the duty cycle on the heating element. Which for something inexpensive like this, I'm thinking that's fine. That's all I would expect anyway. But the one thing that I don't like about this is, okay, so we've determined that this is hot coming in to this board here. Neutral is coming over to this guy. And so take a look at this. This really alarms me, actually. So we can see this is the hot side of the heating element here, which is tacked off of this. This is coming directly off of, whoops, I'll get that back in frame. This is coming directly off of the triac. So here's a nice big fat trace from the triac, and it leaves to the heating element. Well, take a look at this. The same point also comes over to 2 points of the potentiometer. So the potentiometer, these 2 points here, are also sitting at the same potential voltage as the power lead that leads over to the the heating element. Now, I did take a look. This is an insulated, well, somewhat insulated item. There's a ring inside, and obviously, so this terminal here on the side would be the same potential as this knob. But this knob is not common to any of these guys. But I doubt if this knob is rated to have line voltage on one side of it. I just wouldn't expect that. Maybe that's done in some cases. I'm not sure. I don't like that idea. And the other thing that's really, really strange. Okay, so here's the on-off switch. So normally I would say that I would like the unit to be on when you push it up. But anyway, so it's off when you push it up. Whatever. And it's on when you push it down. So when you push it down in the on position, that's actually shorting out these upper two portions of the switch. When it's off, it shorts out these lower two portions of the switch. And if you take a look here, this red wire, now remember this blue wire here is hot coming in, and it's hot all the time, goes through this fuse. So at the other side of the fuse, you can see there's a trace that comes down over to here. And this point right here, which is a fused 3 amp point, is where this red wire is connected. So you have hot on here all the time, fused with a 3 amp fuse. And you can see when the unit is off, like so, you have 110 volts put onto this point right here, which is one side of your heating coil, which also happens to be the one with the bare wire on it. So when it's off, there's actually 110 volts on this thing. So I have no idea why they wouldn't design this, the way I would think it should be designed, where you have your hot coming in and you just use 2 of these connections. You run your hot to one of the connections. So let's say if up was on, and you would run it to the center here. You would run it out from here into your fuse and through your circuitry. And your neutral would just be connected hard to your other side. I have no idea why they designed it this way. Maybe somebody can chime in and give me some insight. So what I'll do is I'll put some high-resolution pictures in the Hacked Gadgets article on this. So if you want to take a look at the circuitry in a bit more detail, go to hackedgadgets.com, and it'll also be linked in on this article, so you can take a look at how this is actually laid out in some more detail. But I'm thinking what I'm going to do with this guy is rewire it so that it works the way I think it should and is safer. And by all means, if you have one of these guys, don't leave it unattended. I would double check that this ground is actually a true ground, that it makes its way through, so that at least the chassis is well grounded. And you might also want to absolutely turn this thing off when you're not using it. And not off with the switch, but off by pulling the plug or hitting a switch on a power bar. Anyway, that was the review of this thing. I won't be using it until it gets some repairs to make it a bit safer.